Yeah, so when we want to calculate arrangements of things, we're given a whole list and we want to know how many different arrangements we can make, meaning how many different ways we can put all those things together. We use factorials. So on your calculator, there's a little exclamation mark, and that represents a factorial. And what that is, so for example, if I say 5 factorial, it means we say 5 times 4 times 3 times 2 times 1, because that's how many things would fill the boxes. If I had 5 things and I want to arrange them, so I'd put first, I have all 5 to choose from, and then I put something in that box. Then I've got the next one, so now I've already used up that one, so now I have 4 left to put into that box. Then once I've put both there, then I have 3 left for the next one, and then 2 left, and then 1 left. So those are all my different ways of arranging, and that's how we use a factorial with an exclamation mark to represent that that's what we're doing. So if we look at an example, I have to find the number of different arrangements that can be made using all 9 letters of the word cameraman in each of the following cases. So when there's no restrictions. So what that means is all those letters could be placed anywhere. So what we do is we count up how many letters we have. So we have 9 letters in total. So we say 9 factorial. And then we have to remove any repeat letters. So we say 9 factorial divided by our repeat letters. So in there I have 1, 2, 3 A's. So I say 3 factorial times 2 M's. So I say 2 factorial. And when you type that into your calculator, you should get an answer of 30,240. Then they say the A's occupy the 1st, 5th, and 9th positions. So that means I have A first, then 2, 3, 4, and then an A for the 5th position, and then 6, 7, 8, and then an A in the 9th position. So those letters have already been given their own specific places. So we don't need to include them anymore. So we leave the A's out, and we only need to arrange the letters in the spaces that we're missing. So there's 1, 2, 3, 4, 5, 6 spaces there. So we can say 6 factorial, and you still need to remove the repeats, but now the A's already have their places. So we don't worry about the A's, the only repeat letters are the M's. So we divide by the 2 M's. And when we type that into our calculator, we get a final answer. And then there is exactly 1 letter between the M's. So that means I have an M, a letter, and an M, and then all the rest of the letters. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so then I have 1, 2, 3, 4, 5, 6, 7 places to fill. So I can say 7 factorial. Removing my repeats because now the M's have their places, but the A's could be anywhere. So I remove the A's by saying 3 factorial. But then I didn't specify where those A's and M's need to be. They just need to be separated by a letter. So it could also be a letter, an M, and then all the rest of the letters. Or I could have moved the M 1 more over, so I could have had 2 letters and then the M, and so on, and I keep moving that M across. So when I do that, I find that there's 1, 2, 3, 4, 5, 6, 7 places that there could have been, because the only other place, that's the very last place those M's could be separated by a letter. So that is the 1, 2, 3, 4, 5, 6, 7 places for all the M's to be. So I need to take this and multiply it by those 7 options, because I could move the M all the way around. And when I do that, I'll type that into my calculator and get my final answer. If we look at another example, I can do exactly the same thing as I do with letters, but with my numbers. So here I have how many 5-digit odd numbers can be made with the digits 2, 3, 6, 7, and 8 if the repetitions are not allowed. So if they're not allowed, that means that we're going to have each letter, and you would put one digit in there, then the next digit, then the next digit, and so on. But the last digit has to be odd, meaning it must be 3 or 7, because those are our only odd numbers. So now we have all the other numbers, and there's 4 places for them to go. So we would have 4 factorial, and then the last digit could be a 3 or a 7. So there's only 2 options there, so we're going to times it by those 2 options for all of our combinations. And then if the repetitions are allowed, so that means that in any box of those 5, we could have any number except for the last digit, which still needs to be a 3 or a 7. Over here, I have 5 different options it could be. So there's 5 numbers for there. Then over there, there's 5 numbers. There's 5 numbers, and there's 5 numbers. So remember, we're multiplying each of those. So that's the same as saying 5 to the power of 4. And then my last digit, there's still only 2, so I multiply it by those 2 for the last digits to get my overall answer. And then the other thing that we can have with arrangements is probabilities of arrangements. So probabilities of arrangements work exactly the same way as all our other probabilities. We say probability is going to equal what we want, so the desired thing, divided by all the total options. So in this example, I've got 8 letters of the word reserved arranged in a random order, and I want to find the probability that the arrangement has V as the first letter and E as the last letter. So my desired arrangements is going to be V first, then my other letters, and then E last. So if we look at that, the V has a place and the E has a place. So then we got 1, 2, 3, 4, 5, 6 places left in the middle to fill. So that is 6 factorial. And then we're going to remove any repeat letters. So in there, there's 2 R's. So we're going to remove those 2 R's. And we took 1 E out as its final place, but there's still 2 other E's there. So we're going to remove those other 2 repeat letters. So this is what we want, and when we type that into our calculator, we get an answer. And then the total number of arrangements is going to be the same as saying if it's unrestricted. So we're going to just look at all 8 letters that we have, and we're going to arrange them as 8 factorial and remove the repeats. So we have 2 R's and 3 E's, and when we type that into our calculator, we get an answer. So then our probability is going to equal the thing we wanted with the V first and the E last. So we found that that was 180 over our total possibilities that we found was 3,360. And that gives us a probability of 3 over 56, or 0.0536. If we look at this last example for probability, we need to find the probability that the arrangement has both R's together, given that all 3 E's are together. So we have the words given that. So remember, given that means we're dealing with conditional probability. And when we had conditional, we always took the two things that we wanted together. So we had option A and B, and then we divided it by the given that thing, which would be, for example, the A. So we want the two things together, meaning both R's and all three E's are together. So for our probability, we're going to say the R's and the E's are together, divided by the given that thing. And the given that is that all three E's are together. So we're going to divide that by just the E's together to find the probability. So if we look at our situation in our word, if we want the R's together in the word reserve, there's two R's. So we put our R's together. And we want the E's together. And there was three E's all together. And then we have the rest of our letters. So the rest of our letters would be an S, a V, and a D. So we have the S, the V, and the D. So those must be together. So remember, they count as one thing. The E's count as another thing. So there's 1, 2, 3, 4, 5 things in total to be arranged. So we say 5 factorial. And then the R's are already together as one thing, and the E's are together as one thing, so we don't need to worry about the repeats because they've already been removed as separate things. So we just simply have 5 factorial, which is 120. And then we're going to divide that by just the E's together. So if we have just the E's as one thing, then we still have place for our R, our S, our R, our V, and our D. So we have 1, 2, 3, 4, 5, 6 different things now, because the E's together count as one thing. So we say 6 factorial. And then we want to remove the repeats. So the E's, just like before, they're separate as one thing, so we don't need to remove them. But in all of these other letters, there's still going to be 2 R's. So we're going to remove the 2 factorial for the 2 R's. And when you put that in your calculator, you get an answer of 360. So our probability was the R's and the E's together of 120 divided by just the E's together of 360 to give us an overall probability of 1/3. So remember, we can have same probability as before. We can have the given that. The only thing is now, to calculate it, we use factorials instead of decimals or fractions that we've usually dealt with. But it still works exactly the same way for probability, for arrangements.